Today we're going to be talking about the water cycle or the hydrologic cycle. What I would like for you to do is take a look at this picture. I've got several pictures for you to look at, but let's go through some of the processes in this picture. With the precipitation, you know that you can have frozen precipitation, which is snow or sleet or hail, and you can have the liquid precipitation, which would be your rain. Now, when this comes to the ground, it doesn't just necessarily sit there. A lot of it is infiltrated into the ground. That means it soaks into the ground, it seeps into the ground, and goes underneath the earth, where it's stored in what we can call an aquifer, and we'll talk about those a little bit later. But just know that the terminology to use is infiltrate. Sometimes they even call it percolate. Soak into, seep into where this water is into the ground. And eventually what's underneath the ground leads into a bigger body of water. So it can be in snowmelt or runoff. When we talk about if it's not infiltrated, it can go into the bigger body of water too. Evaporation is when water comes off or is absorbed through the atmosphere through bodies of water. So your lakes, your rivers, your streams, things like that. You know, if I were to put a bowl of water outside and then we were to measure and then we leave it out overnight, when we come back, guarantee there would be less water in that bowl than there was before. That's because it evaporated. And it evaporated with the help of the wind, with the help of maybe the heat that's in the atmosphere, and things like that, processes like that. And here is a word that you haven't seen before here with me, evapotranspiration. Now, we typically have used the word transpiration. And transpiration, if you remember, is the movement of water through a plant, the parts of it like the leaves, the stems, and the flowers. And it's kind of evaporated into the atmosphere. Just like the evaporation, except that's over the water, the evapotranspiration or transpiration comes from the water that's in the plants and the leaves. And it all goes up just like the evaporation process. Condensation is where that water's building up in the clouds. So condensation is a process that helps form the clouds. That's something you should know as well. When the clouds obviously build up so much and have so much water held in them, that's when we see the dark clouds in the sky, and then we see the precipitation in some form. And here's another picture that I have of the water cycle, but I wanted you to see another word that they use here, which was percolation. They replaced that word or replace the infiltration word with percolate or percolation. That just means the same thing, like a coffee percolator where it constantly drips, the coffee drips through the coffee pot, percolates through the coffee pot. This is what we're talking about here, except with water dripping into the ground. So you may see the percolation, you may see infiltration. Those words right there can be interchangeable. So just know that those mean the same thing depending on which picture you may see. And here you see the transpiration, the precipitation. When the snow melts, it runs down and goes into a body of water or is percolated into the ground. This is a little more complex picture, but it actually explains a lot of where the water is held underground. So groundwater, water beneath the surface trapped in sediment and rock, is called groundwater. Most of the fresh water available for human use is in groundwater. So take a look at the picture, and you can kind of see you have your infiltration word. So that's when it rains or in snow melt, you have water being soaked into the ground, and it can carry on into what's called aquifers. Now, an aquifer is just an underground place that holds water, and that water eventually leads into a bigger body of water. Your water table, which we'll talk about in a different slide too, the water table, let's just say, is right here. So if there's a lot of rain in a particular area, that water table will rise up a little bit closer to the Earth's surface. If it's really, really dry, your water table will drop. But you can see there's an aquifer here, and then there's a silty layer of soil here, and then you have another aquifer, which is down low, which is a confined aquifer. The brown part that you see in this picture would be, it says your fractured rocks or your fractured areas, and that's where water can seep into those places. So water is stored underground in your cracks and in your pores that you have also. So just because we can't see the water, there is water under our feet and is in constant motion. In this picture, you have something called natural recharge, and this is one of those words that all that means is, let's just say the water table, you see where the water table level is. If the water table gets really, really low and drops, eventually it needs to be recharged, or more rain needs to fall and charge it back up to a somewhat normal level. So if it drops down below that water table line for a long time, maybe because we had a drought or we had an extremely dry summer, the water table would drop. In order for it to be recharged or to get back up to a normal level, rain would have to fall to replace that water that was lost. So you may hear the term recharge rate. What's the recharge rate of the water table? In this picture, this is an example of the aquifers that are underneath the Earth's surface. And you can see the confined, which is the deepest one, aquifer. And then you've got that layer of clay. And then an unconfined aquifer, which is the one closest to the water table. And you can see that the body of water in the aquifer runs to the larger body of water. In this case, it's the lake. And I pulled up lots of pictures so you could see. I like this one because it showed how the water was stored in between the rocks, where there was a little bit of air in the gravel and the creviced areas. You have it has the ability to store water. So you have groundwater. You see where the water table line is. Unsaturated means it's not wet. Saturated is your wetter zone. So unsaturated, the drier. Saturated would be wet. I've shown you that picture before. In this picture, what we have are two different types of wells. And I wanted you to be able to see. Some people put wells in their backyard and use that as their main source of water. Some people put it in maybe to water their crops in their farming land and things like that. But you can have a shallow well or you can have a deeper well. And you see the unconfined aquifer, which is up here. This shorter well taps into that. So it actually gets water from that. Now, the artesian well goes deep down and goes into the confined aquifer and gets water from the deeper part. So you can have a shallow well or you can have a deep well. And this picture is an example of, you can see the home, and this is a different kind of well, but they get the well water from this water source below, which is in an aquifer. This is a hole dug at the beach is a great way to illustrate the concept of how below a certain depth of the ground, if it is permeable enough to hold water, is saturated with water. The upper surface of this zone of saturation is called the water table. This was just one example that they use. You know, when you go to the beach, even though you see the water in the ocean is coming up, it's not there. You can go a little bit further up in the sand, start digging, but yet water still comes up. That's kind of the concept of the water table on a simplified version or simplified way. So the water table, that's kind of the water zone or the water level. And sometimes in this process you can have saltwater intrusion when you put a well close to the coast. And in the coast, by the coast, if it's really, really dry, the ocean water will seep into the well, and it can contaminate it, or it's called saltwater intrusion. So when you look at this picture, you see the darker blue is your fresh water, and then the light blue is the ocean salt water. What can happen is when the water table gets so low, the ocean water can mix with the fresh water, and it ends up being a mixture of salt water in your aquifer. So if you live in the area where the well is and you get your water supply from that, you could turn on your faucet one day and salt water come out of the well, which could definitely be a problem, and it's called saltwater intrusion, when that salt water intrudes in on your natural water supply. And lastly, I put this picture up here, so I wanted you to be able to see the different heights in these different types of wells and what they tapped into. You see what's called a shallow aquifer. That's that shallow part and of water, the upper layer, and then you've got your deep aquifer, and then the deeper wells can tap into that deep aquifer. So if the water table, if it's really, really dry and the water table is low, the two shallower wells may not be able to get water or water supply out of it. So that's why some people choose to go with the deep well. Therefore, they know that they can get water when the water table is at its lowest.